So welcome everyone to our webinar on regenerative farm management to reverse ecological decline. Today we are joined by Ian Davis, a farmer based in Hertfordshire who has a focus on reducing the environmental impact on agriculture. Today's webinar will outline the changes UK agriculture has undergone since the end of the Second World War, exploring the major drivers behind the changes and often unintended impacts they have had on the UK landscape. As always, there's a chance to ask questions at the end of the presentation, so please submit these in the Q&A option at the bottom of your screen at any point during the presentation. I will then ask these on your behalf later on. Thank you for logging in, and I'll now hand over to Ian.
Thank you. Hello, everyone. I've farmed all my life, got an HND in agriculture in 1988. I worked for the National Rivers Authority between 1991 and 2014 and returned to full-time farming afterwards. I joined the IES in January this year. I'm here to illustrate how regenerative agricultural management could help to reverse the negative environmental impacts of UK farming. I would just say I have no conflicting financial interests and all opinions are my own. In terms of the structure of today, I'll take you through the brief introduction to the social and political pressures that have driven changes in agricultural practices in the UK, before then outlining the green revolution that increased UK farm output during the 20th century. I'll summarise how today's intensive farming industry impacts the environment and why we must manage our farms differently if we are to address our environmental issues and how regenerative agricultural methods can help this. I'll explain what regenerative farming is and what makes it different from the way most other farms are managed now, before describing how I became interested in regenerative agriculture. I'll offer examples of how looking at our farm differently and managing it with a different mindset can bring a cascade of virtuous ecological change in the landscape. And finally, I will summarise my presentation and leave you with some links for further reading. So the UK was last self-sufficient in food around 1750, since which home production has declined while population has grown. We are inherently a food importing nation. The agricultural depression of the 1930s meant that as World War II began, we were barely 40% self-sufficient in food. And when the shipping attacks in the Atlantic threatened imports, the governments introduced food rationing and implemented the Dig for Victory policy to avoid a food catastrophe. They empowered the War Agriculture Executive Councils, universally known in farming as the War Ag, to compel farmers to produce more food by adding arable land, especially ploughing up extensive pasture and draining peatland. However, ploughing long-term pasture releases large quantities of nitrate over many years, and draining peatland massively increases carbon emissions. This policy formed the foundation of the crisis we see today. After the war ended, the global military industrial companies faced a collapse in demand for their products. It's widely reported that the ammonia industry, which had grown exponentially to supply munitions, saw agricultural fertilizers as the answer, so funded research on crop yield increases from fertilizer use and lobbied hard for continued intensification of agriculture. The chemical munitions industry likewise reportedly saw agrochemicals as their salvation by developing pesticides and promoting their usage. This was cemented in the 1947 Agriculture Act in the UK, which incentivised productivity increases across all agricultural sectors and guaranteed public support for farm modernisation in every way. The Green Revolution had been born. Between 1947 and the UK joining the EU in 1972, the UK Ministry of Agriculture acted as an advisory organisation encouraging farmers to adopt the growing science around high input, high output farming to maximise farm production. After 1973, the Common Agricultural Policy continued to incentivise maximisation of production, using ever more chemical inputs and ever larger machinery until the 1980s. Then European farm productivity increases overtook demand, leading to surpluses in many products. Under the CAP, the surplus production was bought by the EU and stored to prevent farm gate price collapse. before disposing of it years later, often below cost on foreign markets. The voices opposing all this intensification of farming, notably the organic movement and campaigners like Rachel Carson, whose 1962 book Silent Spring I highly recommend, were sidelined as science deniers and Luddites. Nitrogen fertilizer formed the foundation of the Green Revolution, with global usage reportedly rising 700-fold from 1950, and it's still growing. If we ignore methane, which is arguably being unfairly demonized by inappropriately using the GWP 100 metric, then nitrogen fertilizers account for the majority of UK agriculture's carbon footprint. It takes between 39 and 52 megajoules of energy, almost entirely from fossil fuels, to make 1 ton of ammonium nitrate fertilizer using the Haber-Bosch process. That 1 ton is estimated on average to feed only 3 people for a year. According to a 2001 report by the Sustainable Food Trust, we now use an average of 10 calories of fossil fuel energy to produce each single calorie of food we consume. Tragically, we then waste 30% of that food. Those selling fertilizer claim we cannot now feed our population without it, but it's also estimated that up to 70% of all nitrogen applied to crops as fertilizer is not taken up by the crop and instead volatilized back into the air as ammonia or leached out into the soil, out of the soil into the water environment. The Green Revolution has been credited with enabling the incredible growth in UK and global population since 1945 with its huge productivity increases. My father started farm work in 1947 and recalls that 2.5 tons a hectare of wheat was considered a good yield and was only grown once every few years to avoid disease and weed issues. Today, many arable farmers grow wheat almost continuously and average over 10 tons a hectare. In fact, the world wheat record stands at over 15 tons a hectare. The agricultural research industry, funded by the global agrochemical inputs industry, point out that the theoretical maximum wheat yield is around 20 to 21 tons per hectare. But all this intensification comes at a hidden cost. These same processes have been playing out in the UK livestock industry. In 1945, a dairy herd of 20 cows was considered large, and a typical cow gave around 15 litres of milk a day. Now the average UK dairy herd is 143 cows, with many over 250, and 60 litres a day is considered a low yield. To enable such huge productivity, pastures now routinely receive up to 725 kilos a hectare of ammonium nitrate, which provides approximately 250 kilos of nitrogen per hectare, split across 3 or 4 dressings. The war in Ukraine this year has driven prices for fertilizer from £250 a tonne to almost £1,000 a tonne, and many farmers are now starting to question their fertilizer use. From the mid-1980s, CAP policies sought to avoid the cost of managing the surpluses, attempting to match farm production to demand by requiring a varying proportion of land to be temporarily set aside. Later, the EU began addressing the environmental impact of the Green Revolution farming model by applying varying techno-bureaucratic agri-environment schemes, now known as land sparing, to seek to reverse ecological decline on farmland. These trends have driven farm profitability down and led farmers to seek to intensify even further to maintain business viability. A policy approach still being promoted heavily by inputs industry organisations and environmental and animal welfare pressure groups, as well as some politicians who all downplay the ongoing negative impacts. Since Brexit, this has continued, with the current ELMS proposals failing to address the underlying impacts of intensive methods of farming, driving the crisis we see today in biodiversity loss, soil degradation, and farm viability. The Green Revolution did indeed enable a phenomenal increase in farm productivity between 1950 and 2000, but productivity gains have largely stalled since then. Actual yield gains since 2000 have been quite modest, and many arable farms are now looking to optimise rather than maximise output by carefully tailoring chemical inputs in the face of large cost rises. However, they still rely on intense chemical regimes, mostly prescribed by chemical industry-sponsored agronomists. A typical crop of UK wheat will see fertilizer applied in 3 separate doses, totaling between 180 and 200 kilos of nitrogen per hectare, along with a program of 2 or more herbicides, 2 insecticides, and up to 3 fungicides, as well as fungicidal treatment of the initial seed. Root crop regimes are even more chemical-based in most cases. Today, grassland farmers are told pastures should be regularly reseeded using short-lived ryegrass species specifically developed for their optimum response to artificial fertilizer inputs to maintain output. Very little research occurs on low-input farming methods because farm research funding generally depends on agrochemical companies who benefit from selling the products as a result. Most farm advice is often, therefore, little more than marketing. For example, water companies promote the use of sewage sludge as a natural fertilizer, but downplay the very high microplastics and heavy metals content and the presence of many residual pharmacological products. Anaerobic digestion businesses promote their digestate as an ecologically friendly soil improver, but apply it using heavy equipment, which causes significant soil compaction and requires further fossil fuel use to cultivate out that compaction. As for fertilizer use, the Bible of nutrient planning in the UK is RB 209, the official nutrient management guide. It's based on scientific research sponsored or conducted by the fertilizer industry. This is the current RB 209 steering group, and I've outlined the chemical industry bodies in red. Compliance with RB 209 is considered best practice by regulators and industry, despite promoting considerable fertilizer use. Most UK farms have been involved in farm environment schemes of some kind since 2000, with land set aside to provide ecological areas, but this hasn't arrested the species decline on UK farmland. Is our current approach really sustainable? What we really need is an ecologically sound production system that regenerates our ecosystems rather than degrading them. So what is regenerative agriculture? You may well have heard companies claim to be regenerative or to be selling regenerative foods. But what does that mean? Practitioners generally define it by 5 key management principles. These are: cover the soil, minimize soil disturbance, a live root in the soil, maximizing plant diversity, and integrating animals. Conventional farming often leaves soil bare for long periods after harvest or while preparing seedbeds for new crops, and sometimes all winter. It can be avoided by sowing cover crops during the uncropped part of the year. Leaving soil bare can lead to many significant negative outcomes. Firstly, it liberates nutrients in the soil, especially nitrates and phosphates, at a time when there are no living plants to take them up, encouraging leaching into groundwater or rivers. Secondly, it exposes soil organic matter to the atmosphere above the ground, leading to substantial carbon loss to the atmosphere in the form of CO2. Thirdly, it exposes the soil surface to the physical impacts of rain, causing significant breakdown of the surface soil structure and surface compaction. On many soil types, this forms a soil cap or crust, preventing water infiltration, air penetration, and stopping seedlings from being able to emerge above the surface. Often it also leads to soil erosion into rivers, compounding nutrient loss as the silt particles carry agrochemical contaminants. I shall see if I can get this to play. Sometimes it can be awkward.
Water movement into soil. So in these 4 pans, we have the same soil type, just in different managements. In the pans, we have mower, plow, CRP, recently converted CRP to cropland, and 15 years of no-till. So what we'll see is how water moves across the surface in these front bins, and how water moves through the soil and the bins behind it. As you can see, this is simulating a pounding rain on some of these different soil management systems. So you can see on the mower plow pan, that soil is running off the surface and it's actually quite muddy in that first jug. Underneath, there's very little water that's moving through that soil into the deeper into the soil profile. On the CRP, you can see that the water running off of the surface is quite clear, and a lot of that water is infiltrating through that soil, which would recharge deeper in the soil profile. And the recently converted CRP, some of that disturbance is leading to a little bit of runoff, but then also water moving through that soil is still infiltrating. your no-till soil. And you can see that the water that is running off is very clear, but most of the water is actually moving through that soil and infiltrating deeper into the soil profile. After 1 inch of water in this demonstration, you can see how the
that provides a very useful indication of what proportion of rainfall actually percolates down through the soil under different management types, how much runs off on the surface, and just how much soil it brings with it. Lastly, the lack of cover over the soil greatly increases the soil surface temperature in direct sunlight. Indeed, exposed soil will often exceed 20 degrees C or more above ambient temperature for parts of the day. This high resulting soil surface temperature can easily exceed that tolerable by most plants, disrupts active soil biology, and increases evaporation rates, worsening soil moisture loss. Keeping a living root in the soil as long as possible maintains plant supply of sugars as root exudates to the fungi and insect life in the soil. Mycorrhizal fungi are now known to actually penetrate into the roots of many plants in a symbiotic relationship, creating a nutrient access network many times bigger than the roots alone, increasing the efficiency of crop access to minerals and nutrients from a much greater depth and area than the plant roots themselves cover. Cover crops absorb most free nutrients, which are then available to the following crop when the terminated cover crop biomass breaks down, so minimizing nutrient loss. This symbiosis is disrupted if manufactured fertilizers are applied, because the crop plants then cease exuding sugars into the soil and the fungal and animal populations rapidly decline. Like drug addicts, the plants thus become dependent on the use of fertilizers. Disturbing the soil to any depth, generally by cultivation and especially ploughing, destroys soil structure and severs mycorrhizal fungi hyphae. It buries surface organic matter, where it then decomposes, often the intention as a method of weed control, which removes available nitrates to fuel the process and leads to significant increases in carbon emissions. It's a highly energy intensive and costly process, so increases farms' carbon footprint and reduces profitability. Those arguing that this increases soil matter miss the point that the soil is a living system needing active biological soil organic matter rather than an inert substrate to which dead organic matter just needs adding. Nature doesn't do monoculture either, which is inherently more vulnerable to pests and diseases, so lacks resilience. However, most crops are grown as monocultures and planted in spaced out rows to avoid competing with themselves. When herbicides are used to suppress weed competition, this spacing leaves bare soil between crop rows, causing most of the field area to be bare soil. If farmland is allowed to become more diverse, combining plants of different species, then pests and diseases find it much harder to spread, with a significant degree of natural protection shared between the plants. The resulting mixed crop becomes much more pest and disease resilience. This is complicated to achieve in arable systems because modern farming systems are based on managing monocrops, but it can be done with careful choice of complementary crops. So how did I get into regenerative agriculture myself? Well, for me, that leap started in 2017 with watching Alan Savory's YouTube TED Talk about reversing desertification by managing grazing differently. Soon afterwards, I met a farmer in New Zealand applying regenerative principles on his small grassland farm, much like ours. Returning to the UK, I undertook the Savory Network course in holistic land management, began reading many books about soil health and regenerative management principles, searched out relevant scientific papers, and generally became better informed. I began to apply the principles on our own farm and attended Groundswell, the UK's Regenerative Agriculture Show and Conference, for the first time to make contact with other UK farmers using these methods. Farmer-to-farmer knowledge exchange is the primary way in which regenerative agriculture skills are being shared. Historically, farming was very much based on careful observation of the land and crops and adapting management to counter problems. This has been subverted in the Green Revolution as farming has become much more prescription-based, relying on detailed technical advice from paid technical advisors. Key to making the regenerative principle work is reawakening that observation skill, closely observing the soil and land ecology and adaptively applying management, putting much more emphasis on the manager. Here, we now graze most of our farm using the Savory promoted adaptive grazing approach known as holistic planned grazing, HPG, or adaptive multi-paddock grazing, AMP. Cattle and sheep are typically grazed on UK farms by set stocking, shown here on the top left, moving them from one whole field to the next on an ad hoc basis only when they've completely grazed down that field. Some farms operate managed rotational grazing, where livestock are moved into and out of a series of fields in a set rotational pattern based on measuring the forage mass using a plate meter. Both of these management styles result in overgrazing, depressing grass productivity and effectively selecting for the least palatable grasses, although this is hardly explained by the conventional farm advisory bodies or management courses. It's been understood for over a century how grasses respond to grazing pressures. André Voisin conducted a series of experiments in France in the 1940s, which he fully documented in his book, Grass Productivity. He proved that forage productivity could be at least tripled by better understanding the growth pattern of grasses and avoiding regrazing them while they're recovering from being grazed. Alan Savory and others' work has taken this much further and demonstrated that grasses often begin to regrow within days of first being grazed and the implications of this. This diagram shows how the plant roots grow in a reflection of what happens above ground. In set stocking, animals will preferentially eat the most palatable grass first before turning to the rest. These palatable grasses then start to regrow, and because the animals are still there, the new regrowth is again eaten. This traps the plant in this low section of the growth curve. It leads to a selection pressure favoring the least palatable plants. The conventional solution to this is to keep adding fertilizer and to cultivate and reseed the pasture with new grasses every few years. Alan Savory and others have identified that it is therefore the lack of plant recovery time after grazing that actually leads to plant overgrazing and pasture degradation, not the number of animals doing the grazing. Strictly limiting the grazing period based on grass growth rate and leaving long recovery times overcomes this. In spring, when grass grows quickly, livestock must move on within 2 or 3 days of taking their first bite and then stay away for long enough for the regrowth to reach near maturity, potentially from 30 to over 90 days. However, in winter, they can stay in one place for weeks without causing damage because the grass is not actively growing. The resulting management system aims to replicate the grazing pattern of natural herbivore herds, the historic plains buffalo in America or the wildebeest in Africa, where a large number of animals graze pasture at very high animal density for only a day or so, and then move on, not returning for some considerable time. In nature, this occurs because there are no fences preventing them moving. They trample and soil the grasses with their dung, making it unattractive, and natural predators force them to keep moving. The trampled grass then breaks down and, along with the copious dung, feeds the soil biology. In managed AMP grazing, the same effect is generally achieved by using portable electric fencing to break the fields into appropriately small areas called cells and manually move the livestock. While a typical stocking density in traditional management may be 1,250 kilos of animal live weight per hectare, 2 cows, I've been working here with around 105,000 kilos of live weight per hectare, but moving them every 24 hours to fresh pasture. It's been repeatedly demonstrated that stocking densities up to 300,000 kilos per hectare are easily achievable if the animals are moved several times a day, and this generates even more rapid soil health changes. This is simply mimicry of nature, which has had millennia to refine the process. A number of key benefits arise from this approach. Firstly, the animals are grazed too densely to be able to cherry pick the most palatable plants, so the grazing becomes much more even. Secondly, this approach ensures that their dung is evenly spread across the field. In conventional grazing, dung often ends up near the water trough or in the laying area, as this slide shows. The brown dots are actually fecal deposits within the field. The water tank is up here and the gate over here. The animals tend to spend most of their time in this area. They wander off and graze, then come back and lie down near the water tank. So you end up with a net transfer of fertility from the soil from the whole field across towards where the water tank is. This gradual transfer of fertility drives the increasing need for artificial fertilizer use. Thirdly, the plants are able to fully recover and thus maintain their underground energy stores, so they're able to build a much deeper root system. They also self-seed, as in nature, avoiding the need to keep buying in and sowing fresh commercial seeds. All of this drives a fully functioning soil ecology, improves soil structure, aids soil aeration, and greatly improves water holding capacity and infiltration rate over time, as well as sequestering large amounts of carbon below ground in the plant roots and their dependent microbial ecology. It enables a number of financially and ecologically virtuous circles to build up, creating a continuous upward trend in soil health and above ground ecology. A virtuous example I've seen here is that we no longer need to treat our cattle for parasitic worms. Industry advice is to apply insecticidal antiparasitics known as wormers to cattle and sheep at 3, 8, and 13 weeks after pasture turnout. This is to prevent the build-up of lung and gut parasites which impact the animal's health and reduce their productivity. What farmers aren't told is that typically 90% of the insecticidal product is excreted in the animal dung. This leads to a collapse in dung beetles and other beneficial insect species across the pasture and in the soil profile. That stalls dung breakdown and cycling, as this picture shows, forcing farmers to use more fossil fuel in mechanically breaking up the dung with pasture harrows and to have to replace the lost nutrient cycling with artificial fertilizers, all of which may benefit the supply industry, but not necessarily the farmer and certainly not the environment. The left-hand picture here shows a dung pat still devoid of life after 5 days, whereas the right-hand one was taken within 12 hours of our own cows dropping the dung. If you look closely, you can see insects passing across the surface of the dung and disappearing into holes in the dung pat. This is the early stages of dung beetles breaking up dung in the surface. Subdividing fields gives me more control of grazing duration and applied stock density, as this slide shows. By dividing the area, the animals can spend the same amount of overall time in the whole area, but by the time they leave, the plants in the cell first grazed have had protection from regrazing and time for significant regrowth. The more finely the area is divided into cells, the greater the effect. The limitation on this is the ability to obtain water and the effort to subdivide the fields. Set stocked fields typically have a single water trough, so this approach needs more mobile ones. Now, instead of set stocking our herd in this 4-hectare field for perhaps 4 weeks, I divide it with electric fencing, as shown in these cells here, into 20 cells, each of 2,000 square meters, which I only graze for a day. The cattle are forced to graze less selectively and cycle the nutrients much more effectively in each cell. And by the time they've grazed, they've cycled like that through all 72 cells in our 5 grazing fields. The parasite eggs in the dung have hatched and died for lack of a host to grow in. It therefore breaks the parasite life cycle. We stopped using wormers 5 years ago, and our cattle now have extremely low parasite burdens. But more importantly, we've seen dung beetles return to our pastures and the dung is cycled rapidly. We're also seeing a huge rise in other insect life in our pastures now that we're no longer regularly spreading insecticidal products across them. This short video shows the amount of insect life that you get when our cattle move into a new cell. If you look closely, you can see all sorts of insects flying above the crop. This, alongside the fact that our pastures spend more time with diverse, dense vegetation on them, has also driven a rapid recovery in small mammal numbers on the farm. And we now see the whole ecosystem blossoming right up to the raptors, the signature species of a functioning ecosystem. The only birds of prey I recall here on the farm when growing up were barn owls, but we now have breeding pairs of buzzards, red kites, kestrels, sparrowhawks, and several species of owl. When the cattle enter new grazing cells, it's common to see, as in that video, butterflies and dragonflies rising. We're also finding that our water infiltration rates across our pastures are improving. I'm starting to find the surface of our AMP managed fields feels slightly bouncy underfoot, except in the height of dry summers, indicating that soil bulk density is reducing as the life returns, allowing the water infiltration rate to increase. All of this makes our costs reduce and our land more resilient, both to flooding and to drought as the soil water cycle functionality improves. So to summarise, it's centuries since the UK was fully self-sufficient in food. The reliance on imported food became a critical problem in wartime, leading to fundamental government changes in agricultural policy cemented by the 47 Agriculture Act. Policy and research since then has compounded the intensification of UK agriculture, and the ongoing ecological and environmental decline is the result. Regenerative agriculture is a completely different management mindset, which can benefit the farmer and the environment. It's based on 5 simple ideas. The application of regenerative agricultural management has clearly demonstrated benefits in environmental outcomes, soil health, farm profitability, and overall sustainability. That's the end of my presentation.
Great presentation, Ian. Thank you very much. We've got some questions, so I'll just start with those. First one is, great presentation. How can we encourage the kind of farmer-to-farmer learning that drives regenerative agriculture?
That's a good question, and it's something that we're engaging with DEFRA on at the moment. Certainly, the rise in events like groundswell is driving it. Groundswell first started 7 years ago. The upcoming one next week will be the 6th one, because obviously we missed 2020. But there are starting to be similar events occurring elsewhere around the country now. And there's an awful lot of information sharing from farmer to farmer in online sources as well. There are some very good Facebook groups. There are WhatsApp groups, and it is generally ground up farmer to from the ground up farmer to farmer knowledge exchange that provides the real sharing of the methods for this. There are also some very good books out there, but for most farmers, they tend not to be the sort of people that would sit and read a book for long periods of time.
Perfect, thank you. The next question, you mentioned ELMS was a poor incentive for regenerative agriculture. What would a better incentive look like?
I'm a firm proponent for payment for outcomes. The difficulty with farm subsidy schemes is that the outcomes that we're looking for generally take a number of years to really start to measure, and farms are relying on this income to maintain their viability at the moment. I think the way that ELMS has developed so far, particularly the base level of ELMS, the SFI, Sustainable Farming Incentive, is far too prescription based, and that there should be much more flexibility in allowing the DEFRA staff to agree an individual farm plan rather than just the application of standards from a selected list. I think the overall outcomes could be so much better if there was much more tailoring to the individual farm.
Perfect. Christine wants to know if, do you know if equestrians are embracing this for their horse pasture?
Some are, yes, but it's quite a difficult thing to do. The issues around worming with horses need looking at very carefully. Some of the wormers have much less impact than others, but also an awful lot of people who keep horses have a very limited area of ground, and it makes it very difficult to provide the necessary length of recovery period for the grass. But also with horses, there is a problem with laminitis. If they're allowed to graze too much vegetation, particularly if it's quite lush, then horses are very prone to becoming laminitic. So yeah, there are significant challenges, but there are people who are doing it.
Great, thank you. Christine has also asked, have you been able to reduce or eliminate the need to worm?
Sorry, have we been able to?
Reduce or eliminate the need to worm?
Yes, yeah. We haven't wormed our herd here for 5 years now. And because we had some other minor health issues last winter before last, our vets took fecal egg samples, egg count samples, and were amazed at how low the worm burden was in our animals. It wasn't until they'd actually given me the results of the worm count that I told them that we stopped using wormers some years before. So I think it became quite a revelation for them.
Great. Robin's asking, how much traction does the movement of regenerative agriculture have so that the government does something to give it more of a boost?
It's building traction within UK farming, and I think it now is probably the ideal environment for it to move forward, with the massive increase in the price of fertilizers and delivery problems with an awful lot of agrochemicals. If it was ever going to really take off, then it would be now, I think. The problem is that farmers, my experience of farmers is that we typically split into perhaps 3 different groups. There's the innovators and early adopters. That's probably 10 to 20% of UK farmers who are willing to look at new ideas like this and run with them very early on. Then there's the bulk of the industry who they're starting to read a lot about it now in the industry press. They're starting to see some of the people who've been doing it for a few years and making it work. And particularly when farmers talk to each other and say that actually, you know, our costs have dropped, our profitability has improved, we're actually doing less work. We're out there less of the year, chasing around, putting fertilizer on and things like that. Then yes, they'll adopt. But then there is a significant proportion of UK farmers who are so ingrained in the chemical way of farming that it's going to take something very big to actually make them change. It may be that the availability of chemicals and fertilizers, the problems with it since Brexit and since the Ukrainian war, do actually drive even them to start thinking differently. But it does all hang around this change in mindset. And that's not an easy thing for people to do, particularly when you spent your whole life being taught that that's the way it should be.
Okay. This comment from Jackie has quite a few questions, so I'll ask them one by one. Will regenerative agriculture be limited by farm size in order to manage grazing regimes?
Ours is quite a small unit, but I know of people implementing this on much bigger units. And I have heard, in fact, I've seen some Australian videos where they've had herds of 5,000 to 10,000 animals all being moved at once. Effectively, the cells just become bigger. It does introduce some challenges for erecting and taking down electric fencing because you end up going so much further to do it. But this is somewhere where there is potentially quite a big potential for the new GPS-based collars rather than putting up electric fencing to control the cattle. The technology is there now to effectively transfer the electric fence to the animal. They carry it around, and you create a virtual fence for them using a phone app. And as they approach it, the collar that they're wearing sounds an increasing series of tones, a bit like a car reversing alarm. And it's only if they actually try to step outside the zone that they get given a small electric shock like an electric fence would deliver. I've not used it myself, but I'm told that cows acclimatise to that in the space of the first day or so. And then all but the most inquisitive of them react to the tone rather than the shock. And in that situation, your only real challenge becomes making sure that they can get access to water. Although even there, it's interesting, the Australians have found that that cattle in particular can quite happily go for 24 hours without access to water, as long as when they do get it, they can really fill up on it.
The next one from Jackie then is, will livestock farmers need to destock to be able to farm in this way? And then there's another comment, what about animals that are kept inside and they need to spread slurries and manures, and the timing of those applications to meet the crop rather than manage manures in a way that is dictated by available storage?
Yep. Sorry, can you just repeat the first one?
Yeah, the first one was, will livestock farmers need to destock to be able
Yep.
to farm in this way?
Yep. In the short term, as I sort of suggested in the talk, the productivity does reduce, and that can be a problem. It may be that you have to adopt these principles very gradually and wean your land off of chemical inputs in order to avoid having to significantly destock. Once you actually get the system working properly, the pasture productivity increases, and if anything, it's possible to carry even more stock on the same area of land. So ultimately, it could be that by people widely adopting this, you could reduce the area necessary to hold the same number of stock and spare land for other purposes while still maintaining the output. Certainly the issue of housing animals is a big one, particularly in the environment in the UK on the western side of the country where we have very wet winters. It is possible to outwinter sheep and cattle, even in the western part of the country, if you can get the soil health right. If you can get a good free draining soil, and if you can maintain enough cover on top, particularly if you can get a really good strong grass sward going, then effectively that cushions and protects the soil. And in any case, because you're cell grazing in winter as well as summer, they don't stay in any one place for very long. So if you have a particularly wet day in winter and they make a little bit of a muddy mess in one place, they're only there for the day. The next day they've moved somewhere else. If you can do that, that's probably the holy grail of managed grazing, because over half of the costs of running livestock are based around housing them for winter. As soon as you don't house them anymore, you no longer have to produce conserved winter food. You don't have to use all of the energy and the chemical inputs to haul food to them for the winter and then haul the muck out again and spread it. And you don't come up with the problems of timely application of solid manures. So yeah, the ideal is to avoid housing altogether. But if you do, then yes, there's still some quite substantial implications for the how well the process is managed.
Great, thank you. We do have quite a lot of questions. We probably won't be able to get through them all, so apologies for anyone we don't get to your question. So a question here, a great talk, thanks. Beef milk sales will inevitable result in the net export of nutrients from the farm over time. Nitrogen can be fixed from the atmosphere by soil microbiology, but what about the regeneration of phosphorus and other geologically derived micronutrients?
Good point. The same can really be said of all arable cropping as well. And effectively what we need to find a way of doing is closing our nutrient loops. We need to go back to a genuinely circular nutrient economy. The problem is that we're producing all of this farm produce. It's then being shipped over huge distances, and we largely ceased recycling the nutrients from sewage works back onto farmland many years ago. That would overcome an awful lot of those problems, but also they are less evident because of the deeper rooting when you get diverse plants and you allow them to express themselves to maturity. You end up with nutrients being drawn from much deeper in the profile. But yes, there is a potential problem with depletion of the nutrients that the plant relies on that can't actually draw from the air. And at some point or other, there will be a necessity to supplement those.
Great. Okay, we'll do 2 more questions. So this one here, what are the barriers to many more farmers adopting these practices? Yeah.
Mindset.
Okay.
That's the big one. Everyone who's adopted it will tell you that it requires such a change in mindset in order to make it work, that is the biggest thing by far. You have to see your farm completely differently, and you have to make the jump that you're no longer feeding the animal or feeding the crop, you're feeding the soil, and then take it on faith that a well-nourished, active soil will produce the goods for you.
Perfect. The final question, in terms of changes to a farmer's work life, what does the crop animal rotation for regenerative farming add or reduce or have little effect on the number of hours needed to get a good yield?
In livestock systems, in my experience, it actually reduces the time that you need to put in. The Savory Network teach you that you need to take a holistic approach to the planning of your business, and part of that is the social and environmental impacts of it. So again, there are difficulties while you're transitioning because you're trying to make up for shortfalls in production, but once you actually get the system working properly, then you spend far less time chasing around doing all the things that conventional farmers do, which frees up an awful lot of time to be managing the animals more closely. I've had livestock farmers who I've spoken to about it who said to me, I can't be done with all this moving cattle every day. Well, it's actually, my experience is that once I'd set the fences up, which I was doing each time I went into the new field, and it would take me 2 or 3 hours, then it took me longer to walk to them than it did to actually move them. You just open a fence, the cattle are ready, they know exactly what's going to happen. They're looking forward to the next day's grazing. They all run through, you close the fence behind them, you move the water tank, that's it. Compared to that, most livestock farmers will be tearing around with a tractor and a fertilizer spreader several times a year. They'll be carting all sorts of products in and out. I actually found that I was spending less time on it.
Perfect, thank you. I think, I don't know if you've seen in the chat, but there's been a lot of positive comments about how great the presentation was, and you can always tell with the amount of questions that we've had that it's obviously generated quite a lot of interest. So thank you once again for presenting. That's it for us today, attendees. Thank you for logging in.